Welcome to Blueprint for Growth, Innovation in Housing. I'm your host, Amy Billis, Director of Housing Growth Innovation at Digital, Canada's global innovation cluster for digital technologies. Today, we're looking ahead to the future of housing innovation in Canada.
I recently read an article that said we are entering the golden age of construction, and I believe that wholeheartedly. I think we're just beginning. Our industry is experimenting with advanced construction technologies, from modular to prefabrication to 3D printing entire structures. We're using augmented reality, wearables, and drones, and we're utilizing our data to make quicker and better informed decisions.
We'll explore cutting-edge technologies and discuss how Canada can become a global leader in addressing the housing crisis through innovation, collaboration, and scalable solutions. Brey Tucker is a digital strategist specializing in the AEC industry. He leads Tucker Technology Consulting and works with McElhaney Engineering, a major Canadian firm. Brey started as an architect designing skyscrapers with HOK. He embraced early adoption of BIM, leading a career in technology and business strategies, including time as a global strategist at Autodesk. With expertise in both architectural and digital transformation, he offers valuable insights into the future of construction and development. We will explore the shift from traditional practices to digital innovation, data management challenges, the role of language models, workforce changes, and emerging digital business models, emphasizing technology's impact on sustainable housing development. So what I'd love to hit out right away is your views and thoughts about technology deployment within the construction sector and development sectors, where you've seen, the evolution from your experience, where you see innovation shaping the sector right now.
It's really interesting, I think, because there's a huge opportunity for innovation to just keep enriching what would be something that I call biblical BIM. Biblical BIM is like late 70s, Chuck Eastman out of Georgia Tech talking about this, really and complete digital ecosystem of you design a thing, you build a thing, you do maintenance and kind of record keeping on a thing, and then you renovate a thing. And it's all in this one like digital land. But we've never actually done that. And the thing that's interesting, there's this opportunity, especially on the permitting side of things, for a lot of automation and improvement around either standard design blocks and in terms of like housing units and different things that people are trying to do for, at scale development. And then there's also just this piece of we are still very paper-based from a legal contracting kind of perspective. So I think, Europe has had some success in terms of going more digital and having less paper-based reviews, less paper-based permitting. But here in the West, we're still very, very stuck in paper. And so a huge technology that I hate is the growing use of PDFs. And so there's, we have all these things that are on top of PDFs that we're using as opposed to, real database information connected to a 3D environment. So it's interesting. I think most of the innovation that's happening is actually in the construction side. So we're seeing like passive-based capture technologies with either a reality capture device or just with simple like security cameras. And then we're starting to automate kind of project management and kind of tracking and completion work. That's super fascinating because I think there you can have a lot of, post-mortem conversations after a project on, what went well, what was unpredictably taking so long, like where were our design issues. And I think especially for, governance, those are really valuable things to know because that's like detail review, details that don't work, details that leak, things like that. Those are things that I think there's a lot of room for innovation that's probably going to happen sooner than a lot of the stuff that should have happened like 20 years ago because we're stuck in paper-based delivery.
My experience was the catalyst of COVID, sort of quantuming to a place where we couldn't accept paper drawings. And so we all of a sudden had to move 2 years, full steam ahead, which was actually very, very useful for the work that we were doing at the time too. So technology as a catalyst for change is like catchphrase I'd put on a bumper sticker, that's for sure.
This is fascinating stuff. The emerging field of artificial intelligence is the new frontier of tech innovation. We know this, right? But we see it in everything from entertainment to robotics and now advancement in construction.
They upload all the documents. I mean, it's typically tens of thousands of pages, spec books and budgets, the actual plans and questions with the architect, contracts, everything you can think of gets uploaded.
A big one that can help support some of this stuff, obviously AI, generative AI. Where do you see that playing a role in current state?
So I think the best thing that generative AI is doing right now in current state is just simplifying the complexity of so many things. I am finding large language models to be a tremendous tool in sussing through 1,000-page documents. And so it's nice because all of that, and I talk about this a lot at McElhaney, but huge difference between information and data. When you get a book, it's a lot of really high value information, but none of it is data. Most PDFs, none of it is data. Most Excel files, none of it is data. So it's like to actually have data, I'm seeing a huge opportunity with Gen AI to go comb through really complex, large documents, do information extraction, and then kind of data creation. I think that is a huge opportunity for the industry because we keep adding rules for design, and we keep adding all these requirements. We have all these ethical concerns with practice of architecture, practice of engineering. So there's just lots, too much any one mind can work with. So I think it's really good to have these tools that are very, very good at kind of reading through semantics, making a good judgment call on kind of interpretability of a clause of something, and then just giving you that heads up, like, oh, hey, that's probably not going to work for ABC reasons. And then if that turns into something that you want to make a proper semantic around in your common data environment, now you have a tool that can just go grab and spit out your rules that you want to design by. So that, I think, is a fantastic use of it.
No, I love it. And I think you touched on a couple of things there. One is obviously using AI and language models to capture that data and create usable data to sort of like reframe away from discretionary decisions, because ultimately regulatory are rules and conflicting. And we have a lot of that causes delays on projects. So being able to do that. And what I kind of love about it from that data capture piece is analytics. So from now on, it's like once we've got those rules digitized, how often are we, relaxing a rule? And then maybe we should consider using that for decision making around how those rules are created, certainly. So that's a big piece for me, like how they're changing priorities in housing and whatnot. And I love that they'll challenge the status quo once we get a bit more data maturity within that, especially the regulatory environment. So one big piece I wonder, obviously all of this is all trying to lead technology towards efficiencies and reducing delays, controlling costs, all that sort of stuff. How do you think the workforce is going to navigate any sort of skills gaps, or how do you see them showing up, meeting the needs here and the new absorption of technologies, or, when we talk about innovation in the sector, sometimes it's not innovation, it's just going back, doing it as you said, and just doing it a little bit different of a way. But how are we going to manage the workforce? Because we do know that we are within a constrained workforce environment within the construction sector and development sector.
Yeah, absolutely. I think workforce issues are going to continue to get nuanced and harder because I think that, we have the largest amount of retirement that's going to happen in the next 10 years. And we're going to have an experience gap that's going to be massive. And then we're going to need all the tools that we can have to try to bridge that gap. But we also have a huge amount of demand for more things. So, more construction, more homes. And we have a construction workflow gap that's not addressing that. So, I think there's probably going to be some hard periods of readjustment where, construction is going to have to cost more. So those laborers can be paid more and that can start being an attractive workforce again. And then, on the technology disruption side, I think for a very long time, basically since like the late 80s, early 90s, there's been kind of this standard of how you draft and how you deliver work. And the designing of buildings is going to get probably a bit more complicated in terms of data matters. And this industry has been operating with basically zero data for its entirety. Because, draftings and vector-based drawings, there's nothing we can suss out from that. And so I think that's where there's going to be a lot of, transition into, okay, well, what's the difference between information and data? How can I leverage some of this stuff on my projects? How can I build libraries of things that, we've already done once? And it's a compliant fit for what we're doing here. And so those, algorithmic types of thinking and then, really data-based approaches, that's going to be different. So it's interesting. I think there's some stuff there where existing staff who are probably in like mid-career, so like late 30s to maybe like even early 50s, where you're going to have to completely change the way you work and learn a lot. So totally learn respect and approach for data and how you incorporate that into delivering work.
So one more question, and this is one of my favorite ones to ask, because you can freewheel this as long as you like. The future state. We know where we're at. We know we got a bunch of tools. There's things kind of percolating. For you, when you sit in your chair wearing all the hats that you've worn, what do you see in 5-10 years that excites you, that you're like, oh, this is going to be super rad, or I can't wait for us to get past this hurdle so we can do this?
I think there is a really exciting future opportunity for every design consultant, both architects and engineers, to step into a new type of contract where they are going to be managing digitally based solutions that are part of the overall project delivery and asset management lifecycle. So there's an opportunity, I think, for everyone in the space to we're all going to transition into more digitally based deliveries and digitally based management. And I think it's interesting for consultants, they're already really comfortable with multidisciplinary contract relationships. So if you're doing this asset management thing, Autodesk just becomes one of your subs that's on the project. And then you're using their platform to do different things and you have different goals. So I think that's really the future, I think, for digital twins. We have to solve that contractual piece. But for me, I think it's really exciting because those companies that are up to think about it, it's an opportunity right now to define your perspective on how you want to manage it and what matters.
Tony Yang is a professor in the Department of Civil Engineering at the University of British Columbia, specializing in developing technologies to improve structural performance, making buildings faster to construct, more resilient, lower in carbon, and smarter. Our discussions explore the future of housing innovation in Canada, the rise of AI and digital twins, and the challenges of adopting building information modeling, BIM. Professor Yang highlights the need for collaboration between industry, academia, and government to drive innovations and establish Canada as a leader in housing development. Okay, so just as far as an overview, maybe you could provide around the current climate for innovation and technology adoption in Canada, where we're sitting right now.
Well, Canada is right now in the urge of being able to producing housing, and we have housing crisis, we have labor shortage issue. So we are in the urge of being able to deliver quickly. Our government has been funding the industry and the research domain heavily in allowing us to developing those technology. The technology are not implemented in a day-to-day process, but it has been going through a lot of iteration in research at the moment. So we have seen a lot of early fruits of those research, and now we can see capable technology almost ready to be deployed to the industry. That's where we are today.
In this Alberta warehouse, machines are assembling houses the same way they'd assemble a car.
The same two robots are building all the 25 walls that are going into the same house. And you could see over there, we got two more robots, they're building all the floors.
The company says its AI software means these robots can complete dozens of tasks.
We actually don't expect ever builders to learn about robotics, machinery, manufacturing, and that's why we think there is a scalable play here, where you can now take it to many, many more builders and developers across US and Canada.
Early attempts to use factory robots in construction fell short due to the unpredictability of job site environments. Unlike manufacturing, where robots perform precise, repetitive tasks, construction requires machines that can navigate chaos and handle heavy materials. With a global labor shortage, there's a push to make traditional equipment like cranes, excavators, smarter using AI and sensors, kind of like those self-driving cars. How is the next generation of construction robots evolving?
Robot is not new to us. We started seeing robots in our industry, general industries, making cars, making phones, making computers, making airplanes. But those robots, the previous generation robots, are developed for pure manufacturing. And with the significant shortage of skilled laborers in North America and around the world, we started seeing that maybe we should start ramp up this technology in the construction sectors. So over the last 10 plus years around the world, and of course Canada is taking a significant effort in this area, we're leading it. We started developing the next generation robots to be used in the construction environment. So we started developing the next generation and the current generation of robots that to be used for the industry. And after after a few iterations, we do have many capable machines already being used in the construction industry today. You see the crane, you see the excavators, but right now they are operated by humans. So what we're doing at the moment is that we're making them smart. So basically putting the brains, allowing to putting sensors around it, so the robots will understand what's going on around them and then be able to execute tasks by itself autonomously, just like how cars have been driving.
So next one, big one, AI. Everybody likes to use that. And I mean, I understand it's interlaced in everything that we're doing and innovating with. But as far as AI automation, we've seen it in applications around safety, wearables, things like that have been used in AI. So maybe if you could dive a little bit into how it's being used across the sector and its different modalities.
Yeah, so AI is evolving daily. Every day we're working on the new algorithm coming out, and it's clearly the technology of this generation. So a few generations ago, we had personal computing, we had finite element, but now AI is the day-to-day routines that the algorithm technology we're using today. It's very mature now. We can use AI to do autonomous works now. For example, exactly the example you mentioned, we can use sensors and AI to map up 3D environments. So we have started developing that. We use this AI to do predictive works. For example, with certain trends detected, we can actually prevent it from happening. We can use AI to do routine quality assurance work in our construction industry, where we say, hey, we train the AI to detect certain features that we wanted to do. For example, do we see any cracks in the wall? And you will continue routinely going through and identify that. Basically, we develop drones to fly around the construction site, and everything the drone sees is what we turn into a digital twin technology. So you will see everything like those video games. You see everything is rendered, but it's done by AI. It's actually turned into 3D environment, and you have precise measurement inside the 3D world. And we're also developing the next generation AI technology to do what we call object recognition capability. So we have developed that technology. And the other portion of the AI technology we have developed is the algorithm we developed to control this heavy machinery with the hydraulic controls. So with all this integrated together, this is what you have seen in our demos, that when the drones fly around, you see a digital environment, and then the management team will understand where things are and will start executing the things by moving and develop algorithms to start placing and build out those buildings.
BIM is using this advanced 3D modeling to create a virtual model of a structure, and you're seeing folks use this and really improve the accuracy of their projects. I think what BIM really is, it is the gateway drug to actually getting into digital twins. I think the promise of the digital twins is now it's really about automating operations. It's about automated progress monitoring. It's about resource planning and logistics, better safety monitoring, better quality assessments, better optimization of equipment usage.
Digital twin technology is advancing rapidly, but it's a relatively new concept. Over the past 20 years, we've used sensors to monitor infrastructure like bridges, building, measuring vibrations and moisture to predict failures and prevent disasters. Now with your partnership with Rogers Communications, you're developing a 5G-powered digital twin for construction sites. This will allow for real-time remote monitoring of equipment, workers and materials, enhancing safety and efficiency, also supporting automated construction using AI for quality assurance and intelligent material placement. How do you see 5G and digital twin technology transforming the future of construction?
With the advancement and with the speed of Internet of Things, and now those sensors are become cheaper and more efficient for us. Now we can put a lot more. And with many more information, and in fact, now we're able to do a digital wall about any infrastructures where we're looking for. So what will happen is that we will digitize everything on the construction side. So management can actually be away from the site. So the local site, it's only the very few workers and mostly to shut down the facility if anything goes wrong. So they're more on the safety side. But most of the management side can be actually remote. With the 5G capability, you can actually monitor exactly what's going on in the construction site. At any moment of time, you will know where the machines are, where the workers are, what they are doing, what the status they are, where the materials are, so they can do digital construction management remotely. We are also working with Roger with the capability to develop on-site automated construction, and this digital twin serve as a feedback. So right now with this 5G capability, we're setting our sensing technology for the full construction site. And when the goods coming to the construction site, and just like Uber's now, you are developing a network of supply chain coming to our construction site. Along the way, the 5G network or the IoT things would know, oh, my beam, my windows, my electrical plumbing system are coming a different schedule. Once they reach to the site, they are once again using our digital twin technology to do an AI technology to do quality assurance. Once they are sure, okay, this passed the quality assurance, and the AI will start moving those parts to the right place and start assembling. And that's the technology we're doing today.
Building information modeling, or BIM as we often refer to it, has been a hot topic for years, with the promise of streamlining end-to-end development by integrating multiple trades like structural, electrical, mechanical, and more into one single platform. Despite its potential to reduce downtime, errors, and inefficiency, widespread adoption remains a challenge. What do you see as the biggest hurdle to BIM adoption, and how can companies overcome unlocking its full value?
So the idea of the BIM is potentially having a software platform allow all trade to work on the same thing. So as I'm changing my structures, and the electrical mechanical plumbing will actually figure it out. And as they started changing it, that the other trade can figure it out. So it's a very important and milestone in technology where we could potentially reduces the downtime, overlapping, and potential mistake. But it's not 100% adopted by the industry today, and why? And it's mostly because the technology are continue to be evolving at the moment. So the companies are not fully endorsed on 100% BIM. So they are still using most of their traditional procedure to carry it out. And in some important project where BIM is required, then they will try to work together, integrated to the BIM. Right now, we have worked closely with many of the industry member, architecture, electrical, mechanical, plumbing, trying to figure out what's going on with the state of practice of now. And we just had a very large interview for many companies. Understand, some company uses a lot and they say this is 80% what we're doing. Some company says we never use it, and we ask why. And in order to do that, they need to have the skill set of the people who are capable of doing so. So not all companies have that skill set of allow them to do that. Right now, we are trying to resolving this bottleneck by setting standards. With this digital BIM or building information model, with this digital information we have, we can do a lot more. Why do we break it down into basic BIM, intermediate, and complex BIM? Because as your design progress, and you don't want to spend all your time developing and you're not using it. So in the early stage of bidding, we require company to send in the basic BIM. And the basic BIM had basic information, what material they are, what geometry, and roughly how it is about. With that information, it will allow management to actually do very high level cost estimate, and even to understand down the path what kind of carbon emissions that we are expecting to have.
So how would you see encouraging, from an academic lens and the rubber hitting the road, how would you encourage the private sector to get involved or work within the sphere of investing in innovation?
I always felt that our research would not be useful if we never use them, we never work with the industry. And the real research happened when we interact with the industry, and we're grateful for you to tie us to work with the industry. First of all, communications, series like this allow them to know what's coming. It's not a Hollywood movie. This technology are ready. It's a good start. But more importantly, when we sit down together, understand where the bottleneck on the construction industry or whatever the industry are, to understand what's slowing them down, what's costing money. If we have very specific target, and then if we can provide the solutions for that, then it will be win-win. We started this procedure by interacting with lots of our industry partners. They came back to us, say, Professor Yang, we have these issues. We have lack of skilled workers, and we have we don't have an efficient way of constructing it. So over time, when we start hearing their bottleneck where they are, we started developing solutions that could potentially solve it. But this is not one side. It's not something that we develop something and trying to find a market for it. It had to be interactions. So they tell us where the issues are, and we work closely with them in developing this technology. And then once it can be matured, then it can be scaled up to many other partners in the same industry.
So the big last question, which I can't wait for your answer, is the future of construction and development. Where do you see us going? And I'm not thinking 30 years down the way. I'm thinking 5, 10 years. Where do you see the big developments coming, or where would you like to see them or encourage us to go to?
I think in the next 3 to 5 years, you will see significant change the way building construction are being built. You heard about modular constructions, that ability to build off-site and assemble on-site and offer multiple magnitude advantage, where we reduces the demand for the on-site skilled worker requirement, where reduces the environmental impacts on the on-site area, where reduces the waste of the construction waste on-site, and all those. And I think in the next 3 to 5 years, you will see a lot of these prefab constructions being assembled on-site. And you will see these new robots actually working hand in hand in start assembling those on-site. So I think in the next 3 to 5 years, you will see some sample projects being built. And maybe in the 10 years, this will automatically be the way things could be done in the future.
I'd like to thank Brey and Tony for their insights and coming on the show today. As we conclude our series, it's clear that Canada has the potential to become a global leader in housing innovation. The technologies and approaches we've explored have offered exciting possibilities for creating more efficient, sustainable, and affordable housing solutions. Remember, whether you're a policymaker, industry professional, academic, or simply passionate about housing, there's a role for you to play in this transformation. Let's work together to shape the future of Canada's housing landscape. Thank you for joining us on this journey of discovery and innovation. This podcast is just one way Digital and folks you hear in these episodes are working together to accelerate housing production and position British Columbia as a leader in housing innovation. But there is so much more that we're doing. Digital's Housing Growth Innovation Program invests in mission-driven projects targeting key housing issues, as well as encouraging collaboration and information sharing through workshops, events, and more. We'd love to hear from you. Reach out through our website at housing.digitalsupercluster.ca for more information. This podcast and Digital's Housing Growth Innovation Program are made possible with the financial support of the Province of British Columbia through the Ministry of Housing and Municipal Affairs.
Another Everything Podcast production. Visit everythingpodcast.com, a division of Pattison Media. Subscribe wherever you get your podcast.